Hello, my name is Stefano Torresi, and I'm joined here by my colleague Dario Maiocchi, and this is the session about monitoring your high available SAP clusters with open source solutions and SUSE. So let's see what we are going to explore today. We are going to talk about, in general, monitoring and the concept of observability for what regards SAP systems. And we're going to see how is the current status of affairs and how we can try to improve the things. We are going to look at the open source project that we picked to propose our solution. And we're going to also present what we've been working on in the past few months for what regards some data layer that we are using to export the data from your cluster and then use it to present it in a few monitoring dashboards that we're going to show you. And this will be accompanied by some live demo where we show you how the actual thing works. And then we're going to briefly give you some hints about what the future has in preparation for you. So let's get started. The current status of SAP landscapes is that they are very complex, notoriously, and they are very complicated to monitor. They involve a lot of components. They have a lot of moving parts. And if you consider also the SUSE high availability solution with the HA extension, we add even an additional layer that adds even more complexity. And this additional layer comes with the respective tools and procedures that you have to follow to introspect your clusters and your systems and figure out what's going on in your infrastructure. So the current status is usually approached in a very reactive manner. So you tend to inspect your system after something went wrong, and this usually involves even logging into your machines manually. There are, of course, bespoke and custom solutions for approaching this problem, but we wanted to try to propose a generalized approach leveraging open source software and package it under the SUSE umbrella. To rethink a little bit the monitoring, we need to introduce the new concept. It's a relatively new concept. That it's kind of a buzzword, but it has some reasoning behind it, and that is observability. Observability is kind of a new data-driven approach to monitoring infrastructure, and it revolves around getting the data out of your infrastructure. So usually this happens by implementing some middleware that is only focused on getting the data out of existing infrastructure. So it's not an intrusive approach usually. It usually means that you add some sidecar projects to the infrastructure and you get the data out of it and you introspect them. And then you centralize the way that you ingest this data and you store it and make it available for querying. So it revolves very much around properly designing the data model of this information that you have, this operational information that you have about your infrastructure. Once you have this data model in place, you can take advantage of some common and standardized interfaces so that you can combine different software that are already available in the open source community, and they can all integrate with each other. And so you can use your data in many different ways. This will allow eventually to compose some kind of agnostic system for detection, debugging, and analysis. So you can integrate this very well in hybrid infrastructure, for instance, where you could have the same format of data, the same interfaces that can gather data both from your on-premise infrastructure and existing ones, and also combine it with the new infrastructure you might put in place on cloud providers or something like that. There are two main projects that we are going to explore here, and we are going to use. which are Prometheus and Grafana. They are very well known in the container community because the Prometheus project in particular is hosted by the Cloud Native Computing Foundation, and it's very well integrated with very famous software like Kubernetes, but it can be used for any kind of operational system monitoring. So it's not just a software, it's more of a toolkit and a backend platform, if you will. It involves a few different components, but the main design is very simple, actually. And it's at its core, it's a time series database, which is optimized for a multi-dimensional model for the metrics that you're going to collect about your infrastructure. And it also implements a domain-specific language for querying, which is called PromQL, which is tailored for the line format that these metrics are made of and they are communicated by. And this backend can then be exposed with another project, which is Grafana, which is actually has some very tight ties with Prometheus, because a lot of people working on Grafana are the same people in the team of Prometheus. Mind that Prometheus is actually an independent project. It spawned inside a company, SoundCloud, a startup, but then it was it gained traction, and eventually the governance became completely independent, and as I said, it's now hosted by the Cloud Native Computing Foundation. Grafana, on the other hand, while still being a very prominent open source solution, is hosted by the Grafana Labs company, which offers professional support for Prometheus and also for Grafana, of course, and it's a visualization platform. At its core, it's basically a web application, but it's API driven, so the actual front end, which is a very complex and sophisticated JavaScript application, actually uses a web API in the backend, and this web API is fully accessible. So the end result is a very customizable solution for visualizing your data. And both of these are available in SUSE Manager. You can easily deploy them, and usually they are collocated in the same host. And bear in mind that Prometheus is very simple. It doesn't accommodate for a clustering solution. Every Prometheus node is basically an isolated node, and it stays on its own. You can, of course, replicate multiple Prometheus servers, and they will, as we will see in the architecture, multiple Prometheus servers will basically collect the same data, and in this way you can have a resilient monitoring system. But looking at a little bit more in depth about how Prometheus works, as you can see, the main component is the Prometheus server, and inside you have this time series database. One of the most interesting things about Prometheus is that it uses a pool model. So it scrapes data from a few small components, which are called the exporters. And this allows to have a very simple design where your existing infrastructure doesn't have to be aware of the presence of the monitoring system. So the configuration is very simple and is pretty straightforward. And this also has a few advantages in regards to decoupling the whole monitoring system to the rest of the infrastructure. And if you want to use a push model, rather, you can still use an intermediate layer, which is called the push gateway, which basically makes your pushing metrics a pooling model. So the Prometheus server will still scrape some targets in its internals. As you can see in this picture here, this is very much integrated with Kubernetes, but this is beside the scope of our solution. But just so you can know, there are plenty of Cloud Native Computing Foundation projects that integrates with Prometheus. So using Prometheus, as I said, allows a very clear migration path from just bare metal infrastructure to hybrid ones and eventually to cloud native ones. And they will all take advantage of the same monitoring infrastructure, the same monitoring system. One of the other components that we have in Prometheus is the alert manager, which is basically a broker of events that can happen in your infrastructure. and then it can relay these events to external systems like PagerDuty or emails or SMS systems. So you can combine both the data modeling and the usage of this data model to relay this information to external systems, and you can mix and match at will. Usually the main visualization framework, as we mentioned, is usually Grafana, but we also have an integrated UI, which is useful for debugging and just to play with the server, etc. And you also have API clients and SDKs in all the major programming languages. So at SUSE, we decided to implement our own middleware, if you will, these exporters, which are very small projects, very isolated and focused small projects that the only purpose of which is to collect these metrics from your SAP systems. So you install these projects, these programs in as a package in your nodes, and with minimal configuration, they will start introspecting what's present in your node, and we start collecting these metrics. And then Prometheus will start scraping this data and collect it over time. So we have 3 of these exporters for now. There are also community ones, a few which are developed by actually the Prometheus team themselves. One of these is the node exporter, which is specialized in exporting data about the hardware, the kernel of your nodes. So it's a very low-level metric exporter. But we decided to focus on our problem domain, which is the HA stack and the SAP applications. So we have one exporter under the Cluster Lab organization, which is the organization hosting the Pacemaker project, which is the core of our HA stack. And we have an exporter dedicated to Pacemaker, CoroSync, SBD, and DRBD, basically. So all that regards the high availability stacks, which has to be installed in each of the nodes of the highly available cluster. Then we have 2 exporters specialized for the SAP applications. One is the HANA-DB exporter, which was made actually for first, and it's slightly different from the other 2. It's made in Python, so it requires the Python interpreter, but it basically connects to your HANA database, and it starts doing queries to introspect it. And finally, the most recent we have worked on is the SAP Host Exporter, which is a generalized tool to introspect SAP instances in general, but it has some features that are specific to NetWeaver and S/4HANA deployments. So it can introspect, for instance, the work queue of your dispatcher processes, the enqueue server, etc., etc. But it could be used to extract generic information about any type of SAP instance. And all of these 3 exporters will be available very soon in the SUSE Linux Enterprise server for SAP applications, version 15, Service Pack 2, which is coming very soon. The architecture of this exporter is actually very simple. This is a very simplistic picture, but basically it's some process that, as I mentioned, must be installed in your nodes. It requires usually minimal configuration, and inside it has a few internal concurrent sub-processes or sub-threads, if you will. It's kind of an internal abstraction, but all you need to know is that the metrics are gathered concurrently from different target processes that already lives in your node. So if you have, for instance, the Pacemaker process and your SAP Start Service process and your HANA-DB process, etc., you would have different exporters that would use these processes in their own way, and they would introspect them in their own way. Some of these exporters have multiple collectors. These are called collectors in the Prometheus jargon, and usually they are dedicated. Each collector is dedicated to one of these processes. And they live beside them, and they collect information about them, and then Prometheus queries them and collects this data in this generalized format, which is the Prometheus line protocol. Once these exporters are available and they will start collecting metrics for Prometheus, what's left is the visualization of these metrics, and this is something that we realized is very much down to personal preference. Each administrator, system administrator, will probably want to do their own way, and some of them have different parameters they want to check, the different KPIs that they are different priorities, etc. But we still wanted to provide some kind of baseline for this visualization. So we decided to implement a few dashboards for Grafana, which are basically big giant blobs of JSON code that tells Grafana how to configure the entire visualization, which is made up of many different panels. And Dario, my colleague, later is going to show you how this can customize and be changed at will. And we provided one different dashboard for each layer of the system. We have one for all the cluster that you may have installed in one single networking area. We have one for each application layer, so one for HANA, specialized for HANA, one for NetWeaver or S4HANA, and one for the high availability stack. So these are the ones that we currently are working on, but probably there will be more in the future. So without further ado, I will now leave space for my colleague Dario, and he's going to show you in details all these dashboards and the technical details behind making them work.
So in this demo, I will talk about the SUSE SAP monitoring solution and explain the components and how you can use them for monitoring your SAP systems, NetWeaver, HANA, and the HA cluster. So and how you can visualize the data or get useful alerts. So just a quick introduction about the two core components we use, Grafana and Prometheus. I will skip all the setup and all this kind of information because you can find upstream. So Grafana, and I simplify a lot of things, but Grafana is basically the dashboard which you use for visualize the Prometheus metrics. So Prometheus is a time series database, and basically its function is to get the metrics from the Prometheus exporter and visualize them. So a Prometheus exporter and is a component that you install close to your service or database or component you want to monitor. So for example, at SUSE we have 3 exporters for the SAP. The first one is for monitor NetWeaver. The second one is for monitor Linux HA cluster and Peacemaker and other components. I will talk more in detail about this exporter later. And then we have the HANA exporter, and all 3 are Prometheus exporter, and the HANA DB exporter monitor the HANA database. So in this demo, I already have my Prometheus server installed, and for example, this is the GUI. So the main functionality of the GUI is to query the exporter. So for example, here I want to visualize a matrix for our SAP exporter. So I just type a prefix, for example NLB, and then just select one metric, and then I type execute, and then it will visualize this metric. And then you can also do more complex stuff, but for this presentation is out of scope. But Prometheus has a language which is called PromQL, and you can create advanced queries. So and this is how we use also in Grafana. So Grafana, just a quick introduction. it's the dashboard. So basically what we saw in Prometheus, based on all these metrics, you can create your custom dashboards and visualize all these metrics in a more friendly way and more advanced. So here's, for example, the HA dashboard. We have several dashboards, but we will talk later on this. So, and all these dashboard based on the metrics we get from Prometheus, and the Prometheus server scrape all these metrics from the single components which you install close to your service or component you want to monitor. So just a quick to mention, so I showed the already deployed monitoring solution, but you can also have a look on the automated project, and you can deploy the monitoring solution to various cloud providers. So everything is documented, and you can see monitor cluster, and it will go on more on detail how you can configure and provide with salt. But the monitoring solution is easy enough that you can install from end. You just need to install the exporter on the component you want to monitor and install Prometheus and Grafana server. So let's have a look on what is an exporter more in detail. So I take the HA cluster exporter as an example, but the NetWeaver and the HANA are the same. So, but the HA cluster and the NetWeaver export differ from the HANA because are written in Go, so they have all dependencies in one binary, while the Python one needs the Python runtime. So in the HA cluster export and the NetWeaver one, all the metrics are documented on the specification. So you can see we have a nice documentation, and if you go to metrics, you will see everything is documented with a description and some useful information you can have about the matrix. So policy. So this is all for the cluster, but the NetWeaver one follow the same convention. And the HANA cluster is the HANA database exporter is also well documented, but the export basically all the HANA database query you want to select via the JSON file. So, and an exporter is basically export everything via HTTP. So here, for example, we can see the HA cluster exporter, which exposes all these metrics, and the same the HANA, and these are then scraped by Prometheus. We can go to the terminal and see. So I have already a Prometheus server here, and so imagine I'm on a 315 machine for testing, but all the packages are released on 315 SP2. So if you go to the Prometheus configuration, I don't go to the details, but what is important to take, because everything is documented upstream. Here it's important, here we say all the IP and the port number, because each Prometheus on one IP you can run different exporters. So, and each Prometheus exporter run on different ports, so the Prometheus server can scrape and select different exporters. And that's it. So that's the Prometheus configuration you can need to start. Then you can start the service. And for example, you need also to install, for example, here in the HANA node, you install the Prometheus HANA exporter. In my case, the service is already running. Once you started, of course, you need an HANA database up and running. You will see the status, the system unit, and it will expose via HTTP the metrics. So I will now talk about Prometheus alerts. So you have two ways to consume the metrics. One way is to consume the metrics with the Grafana dashboards, which visualize them. This is mostly when you have a big screen with an operator looking at real time, or you can also do some zoom to get some details, to do some research on some particular time zone, some particular moment. So this is one use case, and the second one are you can consume this metric with Prometheus alerts. And the difference is that Prometheus alerts are an asynchronous event. You don't need someone to watch all the time at the dashboard, but with the Prometheus alerts, once an event is triggered, you will get a notification. So we have, for example, we have a good template. We have created some ready-to-use alerts for SAP HANA. This is a good starting point where you can develop your alerts. For example, we have for monitoring. For example, we have, for example, an alert that is triggered when the HANA resource is down. So we are checking that the pacemaker matrix with this expression, so it's Prometheus syntax, but you can build powerful alerts, and these alerts just take 1 inch, just remove the row. If you copy and paste this, just remove this, because otherwise this is intended to be used on automation, so this needs to be removed. So you can copy and paste without the row, and on the Prometheus, I will show you later. And basically, you will have a synchronous event, and if you search for Prometheus alerts, there is the documentation upstream, and so here we have in the web UI some alerts working. For example, here when an alert is triggered because a resource, a pacemaker resource failed. And in this case, you can configure Prometheus even more to send an email or a message on the chat you're using. Or there are other alerts plugin in Prometheus that basically you can imagine these alerts are just a central endpoint. How do you trigger they are triggered red on green, but then you can configure even more Prometheus to send emails, message on the chat, or other things. So it's just a generic point. and then you can spread these alerts depending on your company infrastructure or your workflow. So this is the alerts, and you can see there in the deployment project on this URL. You can just take all this inspiration. There are some useful alerts you can start, and then build your own. But let's go to the terminal so I can show you where is the file just quickly. So here is the alerts file I have on my Prometheus server, and this is the rules one. And of course you need to configure it on Prometheus, but it's really easy. So you can say rule files, and you want to use the alert managers component, and so on. I don't go to the detail because this is another separate topic, but it's just to give you an overview. And yeah, also to mention that, for example, the NetWeaver exporter is running as the HANA exporter systemd. Also, the HA cluster export is a systemd one. Just to mention, so there is a difference between the HA cluster export and the NetWeaver and the HANA exporter. The NetWeaver export and the HANA export are managed as peacemaker resource. What does it mean? It means that, for example, you have a failure on the node. It runs on the HANA exporter. So you cannot, if the node fails, you don't have any metrics anymore, and this is a problem. Also, you don't have the HANA. So normally in Peacemaker, you have a mechanism to migrate the resource to the other node, to the other cluster node, and we take advantage of this feature for the exporter, for the HANA and the NetWeaver exporter. So if one of these nodes fails, the exporter will migrate also with the resource it's monitoring, so you don't have any downtime. The HA cluster export is different because on this exporter we just run the exporter in every node. So, and Science Peacemaker give a cluster status on each node, so we can, if a node 1 fail, we run on node 2 if we, for example, we have a node 4 node on Peacemaker, we run the HA exporter, the HA cluster exporter on node 4 nodes. So if one node fails or 2, we will have the status on the 3 or 4 nodes. So we don't have any downtime, and we don't need to have the exporter's Peacemaker metrics. Yeah, that's the different component, different behavior. And the last thing I want to show is how we can create and extend our dashboard in Grafana. So let's switch to the web UI. Okay, so we have our dashboards, which Stefano will talk more in detail. And so you can extend the dashboard really easy. So you can create a new dashboard or adding a new panel. I will just show you how to integrate a new graph on the dashboard. So here. So I will show you how to customize different dashboard, and how you can go to the high-level picture, which is the multi-cluster dashboard, which I will talk later. But I want to show how you can compose quickly a dashboard and extend them. So for create a new dashboard, you can go to the create and then click dashboard, but I will not create a new dashboard. I just want to show you how you can extend or modify the dashboard for your needs. So you can go to select one dashboard. So I just take the NetWeaver dashboard, which show the NetWeaver. So, and for extending a dashboard, you just go to add new panel and add a query. And so basically you type each of the SUSE metrics as a prefix. So the SAP is for the NetWeaver, so dispatcher. If I type HA cluster, is for the HA cluster stack, and HANA-DB is all the metric concerning HANA. So in our case, we are on NetWeaver, so it makes sense that we use a NetWeaver, but we could use, you can combine all the metrics you want, so even combine the OS metrics, and others metric in other dashboards. So it's up to you. So for example, I select this one just as an example, and then Grafana show me all the different results. And you can also select the visualization type. So there are really a lot of them supported natively. So you can customize them as you wish. So here is just for the sake. So you can make some description. And you see I have the text. And if I go back, I will have the test dash in our case, and then you can also make it bigger, smaller, you can adjust, and everything will save in the JSON file. You can save and export, and we have, for example, in the monitoring, we have everything in a JSON format saved in Git, so we can save them and then have an history. So we don't manage it directly in the dashboard. Or each change go to in our Git repository. So you can extend, also you can change position. So you can really extend, remove. So it's really user friendly. So you can make bigger, change, remove. Okay, and that's it. So that's how you can extend and create your own dashboard and panels, and then there are plenty of guidelines, so how to create a good dash. And yeah, our dashboard are just templates. You can extend them, because you will need to extend accordingly also to your needs and infrastructure. But they are really a good starting point. I will talk later on this. So I will just show you how you can use the dashboard for investigate about failures. So I have rebooted a node the last 3 hours. So you can see that there are already anomalous patterns here, and the network traffic comparing to the normal, and also on the active resources. So I have removed the HANA cluster node, and if I zoom, we can see that the HANA cluster node up was 2, and then our sample was 1. And the same period is this where the network traffic was so high. And also the same, you can see that the HANA resources were from 4, they switched to 2, then the reboot, and then one resource was migrated. The HANA database itself was running on Node 1, but after the reboot, it was promoted to Node 2, so for the HA cluster purposes. So this is just an example how you can spot common issues. So the time frame issue, the time frame zoom is always a good feature, so you can see a lot of things going on. Why they was here, I don't know. So there are always, you can explore the data. So, but here in this case, I already rebooted, so we know here how to spot. And the same you can visualize on the, this was the multi-cluster, and the same you can see on the cluster dashboard. So last 3 hours, here you can see that there was a reboot also in the peacemaker. So we see that the nodes, they were not all up, because when all they are up, they're online are 2, and in this case they were not all up online. So you can see much more in detail about the status of the node, of the resources, everything changed. The node was recovering, so not everything was up and running. So you can see peacemaker service was down, the exporter was down, processing was trying to recover, and then of course if you zoom later, you can see that it was just a moment and then the cluster recovered.
Okay, so now that you've seen what we have worked so far, just a very brief introduction about what we might be in preparation for the next future. So we're going to definitely add even more metrics, since this solution is very much based on the data that we are able to pull out from the infrastructure that you might have. We need to add even more of it, and this will enable more analytics and even better dashboards. Then we need to add log aggregation, of course, because logging is a very important part of the whole monitoring stack. And in the future, we might like to have an automated deployment system to deploy all of this solution in a comprehensive manner and in a simple way for existing deployments. And we would like to add telemetry and finally predictive analysis, which is a kind of a big deal, and it's going to require, of course, a little bit of time, but this is what we are working on at the moment. So thank you all for your attention, and Dario, you're here with us?
Yes, thanks, Stefano. So thanks for the attention, and see you at the next SUSECON.
See you, goodbye.
Ciao.